I don't know if I've done that before, but that's my turkey call. Straight from my own mouth. And if you're watching this on Thanksgiving, then happy Thanksgiving. Chances are you're not, but maybe you're watching it around Thanksgiving. And if you're not, oh well. Hope you enjoyed your Thanksgiving or will enjoy your Thanksgiving. But either way, this is section 5.1. It's the beginning of chapter 5, and it's talking about mid-segments of triangles. So either way, we're focusing on this goal right here. This learning target of I can use properties of mid-segments to solve problems. So we're going to learn about what mid-segments are and a couple properties about them. So with that, let's start off with right here. This is kind of our definition for today. Connecting the midpoints of two sides of a triangle, create a segment called a midsegment of the triangle. So the midsegment is the line that connects from the midpoints of two of the sides of a triangle. So a picture would be right here. So DE here is a midsegment. And this is our first theorem for this chapter. It's our first property. It says if a segment joins the midsegments of two sides of a triangle, then the segment is parallel to the third side. And, oh, here it is, both of those, and it is half as long. So, if you look at our if D is the midpoint of CA and E is the midpoint of CB, then we can say that AB is parallel to DE, and we can say that DE would be equal to half of AB. Alright, so kind of filling in the blanks straight from that. The midsegment is blank to the third side of the triangle. Well, that would be parallel. The midsegment is parallel. And from the picture, you can kind of tell that as well. But it'll always be that way if it is truly the midsegment. The length of the midsegment is half the length of the third side. And we're going to skip over this third one because it says, well, it's asking you a question, when connecting each pair of midpoints, what conclusion can you make? Well, there's going to be three different mid-segments, but we can make conclusions based off of those properties. So, looking at this triangle over at the right, the mid-segment of triangle ABC are, well, we'd have XY, we would have YZ, there's a Y, and we would have XZ. So those are all the mid-segments based on the picture. We know that they're mid-segments because the sides that, so like if you look at X, these two sides are congruent, so that would be the midpoint, and all three of them have midpoints. So what two things can you say about XY? Well, we can say XY is parallel to AC, so that third side. And then we can also say that XY, the length of XY, is going to be half of AC. So in other words, this is going to be the same length as one of these. Right? You can kind of tell the picture looks like it. So let's apply those properties here. Start with these first three problems. Find the length of the indicated segment. So let's look at number one, AC. AC, so we have AC is, well, this is the mid-segment, DE, and it's 15. So AC would be, since DE is always, the mid-segment is always half of the third side, the parallel side, so it would be, AC would be twice of DE, so AC would equal 2 of 15, which would equal 30. Alright, so number 2, we're given that third side, and we want to find the segment of the length of that mid-segment. So that mid-segment right there, it's going to be twice, or sorry, half of it. So SU is half of, half of RV, or half of 10.6, which would equal 5.3. Alright, why don't you try this one on your own? You can go ahead and pause it and try number 3. It says, find the length of segment GH. Alright, if you unpaused it, GH is going to be twice as that parallel side, to this mid-segment, so it's going to be twice of it, so GH is going to be equal to 30 units. Alright, scrolling down, I got a couple more examples. These are dealing with variables now. So, number 4. We want to find the value of x, and we know that mid-segments are always half of that third side that is not the parallel side. So 3x has to equal 1/2 of 5x plus 7. Or you could have said 2 of 3x is equal to 5x plus 7. Um, so then we could say 2 times this would equal 5x plus 7. Either way, these are going to be both work. I'm going to use the second one just because I like that better. So we have 6x equals 5. So here's my order, sorry. X plus 7 minus 5x from both sides. To get the x by itself, we have 1x over here is equal to 7. Alright? And if you plug that in, I believe it'll match up that AB will certainly be half of ON. Number 5 is going to be very similar to that, so why don't you try that one on your own. When we get to number 6 actually recognizing that BA is, or AB is the mid-segment, so that these sides would be congruent. We can set them equal to each other and solve for x. I'm going to go through number 5 with you, though. So same thing, 2 of 2x would have to equal 3x plus 11. Or we could say that half of 3x plus 11 is going to be equal to 2x. So we got 4x equals 3x plus 11. Subtract 3x again from both sides. And we get x is equal to positive 11. Alright, and if you wanted to double check on number 6, you'd end up getting x equal to, I believe it is 10. It would be 10, yes. Okay, you can just set those two equal to each other. So that's using that one property of mid-segments. Now, let's go take it a step further. You're going to have to review a couple of these formulas in order to do an example like the one below. So let's look at the example below first of all. It says triangle ABC has vertices, so we're given coordinates of it. -4, 1 would be point A, point B is 8, -1, and point C is -2, 9. Segment DE. So I don't even have a graph right now, but DE is a mid-segment of triangle ABC. D happens to be the midpoint of CB, and E is the midpoint of AB. So find the coordinates of D and E. So again, we're going to have to know the midpoint formula. And we're going to have to verify that AC is parallel to DE. So to do that, we're going to have to find slopes. Sometimes we're also going to have to use this distance formula, so that's why I wanted to review these 3 things. Alright? So the midpoint formula. Remember, to find a midpoint of a line, when we're given the 2 endpoints, we take the x1 plus the x2, so that's going to be our first, and divide it by 2. So it's like we're finding the average of the x's, and then we do the same thing with the y's. y1 plus y2, we divide it by 2. So again, we're finding the averages, and that'll give us the midpoint. Distance formula, so d is going to be equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. And then finally the slope formula, that's our m, is equal to y2 minus y1 over x2 minus x1. So if we want to find the coordinates of D and E, we're going to have to use that midpoint formula. So for D, we know that D is the midpoint of CB. So let's use C and B here. And we're going to do the 8 plus -2 all divided by 2. Sorry. And then the y value, we're going to do the y's, -1 plus 9, and then divide that by 2. So our point for D is going to be 6 divided by 2, which is 3, then 8 divided by 2, which is 4. So the midpoint of CB, or point D, is going to be 3, 4. All right, now let's find point E. E is the midpoint of AB, so I'm going to find A and B. So I'm going to take the x's, -4 plus 8, and divide that by 2. And then I'm going to take the y's, 1 plus a -1, and divide that by 2. So -4 plus 8 is 4, divided by 2 is 2. 1 plus -1 is 0, divided by 2 is 0. So D is 2, 0. Now, to verify in point B that AC is parallel to DE, they would have to have the same slopes. So remember there, parallel lines have the same slopes. So let's find the slope of DE. We'll find the so DE, the slope is going to be y2 minus y1 over x2 minus x1. So let's go 0 minus 4 over 2 minus 3. So oops, that's for DE. And we get -4 over -1, which is just going to be 4. Now let's find the slope of, what's the other one, AC. Alright, A and C. So let's do y2 would be 9, minus y1, which is 1, over x2, which is -2, minus x1, which is -4. Okay, top is going to be 8. And remember the bottom, it has to be, when you have minus and negative, it becomes a plus. So it's going to be over 2, which would reduce to 4. Same slopes, they are parallel. There you go. So it pays to know the midpoint formulas, the distance formulas, the slope formulas, especially for a problem like this where you're using coordinate geometry. Now you could certainly plot these points, and it'll help you look at if they're parallel or not a lot easier. You can just do rise over run. Midpoint's going to be a little more challenging though, because there's not going to be horizontal or vertical lines. So last examples I have here. We've got our example over to the right, and I've got 5 questions here. It says, in triangle RST, we know that U is the midpoint of RS, V is the midpoint of ST, and W is the midpoint of TR. And we're given some things. We're given like the value here, 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 and here. All right? So let's do a few, let's answer these questions. So you can go ahead and pause it if you'd like and try these on your own. That would be an awesome thing. See how you can apply what we've learned so far today and use your observations of what we have. And then in a second you can unpause it and check your answers. All right, here are the answers. For RS, we know that RU and US would be congruent here, since those are bisected by the midpoint U. And so RS would be twice of whatever one of those is, and we know RU is 12, so RS would be 24. Number 2, find the value of x. We'll look over on ST. We know that, again, those two parts would be congruent, so 2x equals 11. Solve for x and you get 5. Whoops, that's supposed to be 5.5. All right, number 3, we're trying to find y. Very similarly, we know that 15.9 is congruent to 3y, so set them equal to each other and solve, and you get y equals 5.3. Now 4 and 5, we're dealing with the mid-segments. Number 4 asks for UW. So UW is right here, and that would be half of this one right here, the parallel side. So half of that is going to be 11, based on what we're already given. And then finally, we have trying to find UV, and UV is going to be half of RT, and we know half of RT is 15.9. So there we go. We use those properties, and what other things we know about these parts of these triangles. And so this is typical application of what we know now about mid-segments. So I do have a closing question here. You can look at finding the finding the error here, sorry. And then the closing question says, how is the length of a midsegment of a triangle related to the length of the third side? And that's a key part, really big part of what we were learning today. And going back to our goal, I can use the properties of midsegments to solve problems. Remember those two properties dealing with the midsegments being parallel to the third side, and also half the length. All right? So that's all we've got for the first section of chapter 5, Midsegments of Triangles. We'll be doing a lot more with different parts of triangles in this chapter. All right, have a great rest of your day.